When we talk about implicit function of one variable, we can also compute the normal vector to the curve. If we go back to linear function or straight line, then the straight line has the equation ax plus by plus c is equal to 0. And these two coefficients at x and y are components of the normal vector. If we consider this to be an expression capital F of x and y, then the first component of the normal vector A is the partial derivative of capital F with respect to x. And this is the partial derivative of capital F with respect to y. So the normal vector is gradient of this function f. And this is true even for more complicated functions. If we have the curve given by the equation fxy is 0, then we have derived that the slope, which is the derivative of small f, is minus fx fy. If we have the slope k, then we can consider the tangent vector being 1k. And if we have the tangent vector, then the normal vector, which is perpendicular or orthogonal to this one, can be written as k minus 1. We swap the two coordinates and we multiply one of them by minus 1. So this will be the normal vector, or in this direction. And k is minus fx divided by fy and minus 1. But if I interested in the direction only, we can multiply by minus 1 and we can multiply by fy. And we have fx fy. You see? So this is the gradient of the function capital F, and this is the vector that gives the direction of the normal vector. This can be illustrated by a simple example. Say x squared plus y squared minus 1 is 0, which is the unit circle. And if we call this capital F, then the gradient or the partial derivatives are 2x, and the derivative with respect to y is 2y. So the normal vector, which can be the gradient of f, which is the vector 2x, 2y. Alternatively, we can divide by 2. This is not a problem. And you see that this is an equation of a circle. And at any point of this circle, the normal vector is 2 times the vector of the position. So if this is the position, then the normal vector looks like that. It goes in the same direction, and it is 2 times 1. Well, and this is true even for more complicated curves like that. The normal vector will be this vector, which can be evaluated as the gradient of the left-hand side, capital F.